All right, welcome everyone to my presentation about debugging Apache Airflow and how this led to my first open source contribution. First of all, thank you Pedro for the nice introduction of the big data platform. That's the talk we had right before this. And second of all, sorry for being a little bit late. Apparently my laptop was the chosen laptop that wasn't working. So we had to do some other stuff to transform my presentation. All right. So who am I? I'm Jorg Slijster. I'm 26 years old. I've been working for the big data platform in the core data infrastructure team for about a year now. And yeah, my hobbies are tennis and padel. And without further ado, let's get into it. What are we going to talk about today? First of all, we're going to do an introduction. So what is an orchestration framework and why do we even need one in the big data platform? Then we go on to Apache Airflow and what are the internals? And finally, we go into the actual debugging of Apache Airflow and how this led to the contribution. Let's start with a global overview of what the first things were on the big data platform. We were ingesting data from the Postgres databases from Adyen main and also some other sources from Adyen main. And then on the big data platform, we were using Apache Spark to transform this data into summary tables, but also to combine different data sets together. And also we were training ML models to detect fraud. What do all these tasks have in common? That is that they are batch-based. There's not something triggering it automatically. We need to trigger it somehow ourselves, as it's not a streaming framework. So yeah, that is basically why we needed an orchestrator. So what is the definition of an orchestrator? It's the automated configuration, coordination, and management of software. So our goal with the orchestrator was to be able to automatically start our jobs on a schedule, to be able to define the dependencies between tasks, so that if one task succeeds, only then the next task can start. To have automatic retries, because sometimes due to a blip of the universe, your task fails, and then you don't want all the other tasks to hold, you just want to automatically retry. To have a nice web interface, so we have a better look on how everything is going. And finally, we wanted something to be easy to work with. And that's basically how we came out to Apache Airflow, because originally we started our own orchestrator, of course, that's the Adyen way of developing. First, create something yourself. And that, as Pedro already mentioned, this ran into some limits, and at that time, Apache Airflow was really the go-to tool and was the industry standard. So that's why I chose Apache Airflow at that time, and it really fitted nicely in with Spoink, the previous version, the internally developed version. So the migration was also quite easy. All right, Apache Airflow. It was open sourced in 2014. 2014 sounds like a long time ago. Actually, it's not. Let me refresh your memory. 2014, a lot of people were playing this game, 2048. It had over 10 million downloads in the Play Store, and I was a bit hooked to it myself. I think my house score was in the 8,000. I think should have done better. And also this picture is from the Emmys. It's the most retweeted picture on Twitter, and it had over 2.5 million retweets with a lot of famous people in it. Okay, it was introduced, or I should say developed by Airbnb and open sourced by them. And it's actually one of our merchants, of course. And since then, over 8,400 PRs are merged. And it's used by more than 1,000 companies and more than 1 million developers, according to the creators of Apache Airflow. And also, some of our merchants are using it. So BlaBlaCar, Dropbox, Grab, Spotify, Agoda. All right, let's go into some key features still of Airflow before going into the debugging session. So first of all, it's scalable. So it uses message queues to queue the jobs, and thereby the actual workers, which are on separate machines, they can pick up these jobs asynchronously. and thereby the amount of parallelism is really limited by the number of workers you have. Then it's completely written in Python. That means that it allows for a very dynamic pipeline generation. It's completely open source, which enables this whole presentation because we wouldn't be debugging anything if it wasn't open source. And it's easily extendable. Finally, it has a very nice web interface which allows all data scientists to easily monitor how their jobs are doing. And also the logs are directly accessible there. Finally, we also created a custom plugin, which was quite easy. And this streamlined our DevOps work, or like work to undo tasks, for example. We completely streamlined that using our custom plugin. To give you a bit of a feeling what this web interface might look like, here on the left side you can see the workflows. So, for example, the example bash operator, and then the owner of the workflow, which in this example is Airflow. The number of runs and whether they were successful, are still running, or failed. The schedule, and a little bit of more information there. So let's zoom into this example bash operator. You can see that it has a couple of tasks. Let's start with the top task, the run me 0. And if that task succeeds, only then it will run the task run after loop. And if that one also succeeds, then it runs run this last. And all these tasks are run in parallel only when the dependencies are met. Okay, what is Apache Airflow made of? First of all, it has a web server component, which is just a Flask server running with Unicorn. Then it has a scheduler, and the actual creator of the scheduler, he likes to call it the load-bearing infinite loop, which is responsible for the scheduling of jobs. And then the metastore, which is basically a location where we store all the data. In our case, it's a Postgres database. And then we have the executor. And the executor is a part of the scheduler that is responsible for actually starting the jobs, or it's a part of the scheduler that makes sure that once a task is ready, it actually gets sent to the workers, and then the final part is the worker that picks up this message and actually executes the task. And this is quite an important slide for what's coming next. So what are the states that a task must go through? First of all, a state starts in none. Then once Airflow scheduler picks the task up and checks for dependencies, it's moved to scheduled. Then if the dependencies are all met, it is finally moved to queued. And once queued, it should be started. And finally, one of the final states should be matched, which is either success, failed, or up for retry. And if it's an up for retry, it might go back to scheduled. Or it should go back to scheduled, I should say. So to bring back this to like the components that we saw, the scheduler's responsibility is actually for moving a state from none to scheduled, and then finally to queued. And this part for bringing it to queued, that's where the scheduler really checks if all dependencies are met. So if all the previous tasks succeeded, and that sort of dependencies. And then the executor interface, that's also part of the scheduler. That is the part that's responsible from taking on this queued task and sending it to the worker, then lets the worker do its job, and finally, when the task has been finished, it acts upon whether it was a success, whether it failed, or whether it went to up for retry. All right, we covered the basics of Airflow now, and we can get into the actual debugging. Let me set the stage for this. It was June 2021, and Airflow 1.10, which we were using, reached end of life. So we had to upgrade. The Airflow 2.0 upgrade made the scheduler highly available, and that meant that it had been completely rewritten. So there wasn't a lot, like the previous version had been iterated on a lot, and this was completely new. Yeah, and it was of course open source. Otherwise, this debugging session wouldn't be possible. So we had 150 workflows at the time and around 2,000 tasks, which were most of them running daily. And yeah, on 8 June was our first release to Airflow 2.02. And yeah, this was the beta release. And overall, it could have gone worse. Minor fire, but we managed to extinguish it on time. So yeah, the application started, the most important parts were working, and we only needed to make a small change to our Airflow plugin, and I forgot to refactor some imports, but overall everything was going well, and we managed to fix it really quickly. Then the test release, yeah, we still had some smoke on the horizon from the beta release, but everything went very smoothly. Then later we noticed that there were some tasks being stuck in queued, but we didn't really know whether that was Airflow's fault or whether the developer or the data scientist like made a minor issue in their DAG that caused it to be stuck. So we weren't really sure what to find or what to look for here. So we didn't think about it like a major issue, and we went on to the live release. And that really went as a breeze. Yeah, we were still unable to unstuck this task unstuck this task that was stuck in queued. But yeah, the live release went very well, so it was smooth sailing. But then quickly after, the task on live, or some task in live, also became stuck in queued. Yeah, at this point, we really noticed that something was wrong because more and more tasks were becoming stuck in queued, and we didn't really know what to do. So yeah, minor fire, but we really needed to get to work to fix this. So first thing that comes to mind, of course, is hello IT, did you try turning it off and on again? Yeah, well, that was the most obvious tactic, so that's what we tried. Did it work? Nope. It actually gave us a horrible result. We went from 20 queued tasks to almost 150, and we had over 1,000 tasks waiting at that time. And the most horrible part was that there was no new task starting whatsoever. So even the tasks that weren't stuck weren't running anymore, or weren't starting even. So we were making no progress, and it seemed like Airflow just broken completely. So yeah, major fire, all hands on deck. And yeah, so first of all, why is this an issue? Isn't there another way around? Yeah, sure, in the web interface you can clear 100 tasks, then let the scheduler rerun it. But yeah, that wouldn't work because the scheduler wouldn't run it. And then you could, of course, manually trigger the task in the web interface as well. However, for every task you wanted to rerun, you had to do 7 clicks. Now, think about doing that for 2,000 tasks, and I'm sure someone will have repetitive strain injury in your team, and definitely in the long run. So, all right, we Googled the issue, as you always do when you have an issue. And there were quite a lot of open issues with Airflow 2.0, but only one issue really covered what we were seeing. And as you can see, I highlighted that this issue was from 7th January. So, you know, is this already fixed? Is it not? It's quite an old issue, right? And at the time, there were even 60 comments. So it was quite a hot topic. And what I found quite funny in the description of Overbrid was that he mentioned the task in the queued state say task is in a running state, which is not a valid state for execution. The task must be cleared in order to be run. Well, that is obviously not true. Nothing is running on the cluster, and Airflow is likely just lying to itself. It seems the Kubernetes executor and the scheduler easily go out of sync. And that was exactly what we were seeing, with the exception that we weren't using Kubernetes, we were using a distributed executor. But yeah, it was exactly what we were seeing. So I scrolled a bit further and I noticed some posts from Ash B, which was the actual creator of the Airflow scheduler. So he was the one who completely rewrote it. And he was telling us about that you should send a sick user to command to the scheduler, and was like, what is a sick user to command? And apparently it's a kill command you can send to applications that doesn't actually kill the application. So yeah, that's what we did. And this is what we got. So it said that we had over 128 tasks running, which is our limit. In total, we had 190 tasks running. But again, we didn't actually have any tasks running. Nothing was happening, but the scheduler was saying, as quoted, the scheduler was lying to itself, that it's what 190 tasks running. So yeah, we also looked through the debug logs. So a couple of interesting ones was, yeah, that at the top that it said that it was sending a task instance key, but it couldn't queue it. Then at the middle, we saw that, yeah, again, this 190 running tasks, and it had minus 62 open slots. So, all right, how do you get to minus open slots? I mean, you can have at most 120 running tasks, but apparently went far over it. And finally, the bottom part, it said at the beginning, when we started the application, that it adopted 93 tasks from a dead scheduler, or sorry, a dead executor. Okay, so let's zoom a bit more in on these logging lines. So first of all, the could not queue task instance. So it tried to send the task instance, but it couldn't queue it. So on the code fragment, I'm going to explain you exactly what you need to know from the code fragment. Feel free to read it, but yeah, again, I will tell you exactly what you need to know. So on line 1 to 5, it explains the function, or it defines the function to queue a task. So we get a task instance key and a command to run if we can queue it. First of all, on line 6, it checks whether the task is already queued or whether it's already running. And if it's not queued and not running, only then we're going to actually queue it. If it is already either of the two, it says that we couldn't queue the task because it's already queued or already running. And that is the behavior that we were seeing. So now let's go in a bit more detail on the distributed executor. So this is the class that most of these logging lines are coming from, and let's cover some of the variables, the instance variables that it sets. First of all, it sets the parallelism, which is the number of concurrent tasks we can run, which is 128 in our case. Then it sets the running variable, which is a set of all running tasks. It sets the queued tasks, which is all the tasks that are queued, and then periodically all these queued tasks are being started. And finally, the event buffer, which is to report the state of the task back to the scheduler. So if it finished, if it's still running, or succeeded. Yeah, and what is interesting is the last two variables. It's talking about adoption. And at the time when I saw this, it was like, okay, but what is this adoption? What are we talking about? Well, they weren't talking about adopting kids, but they were talking about adopting tasks from a dead scheduler. So why is it actually adopting tasks from a dead scheduler? When the scheduler was made highly available, it basically meant that for a scheduler, it would pick the task and look after the task from beginning to end, and then once it's finished, it's done. But then if we have multiple schedulers, then if a scheduler dies, the other scheduler needs to take over the tasks. And that's what we're seeing here. So when does this routine kick in? It's always at the start of the scheduler and every 5 minutes. So yeah, what task is it adopting? It's the scheduled, the queued, and the running tasks, because all the other ones are in a state that, yeah, they shouldn't be running anyway. Yeah, so let's take a look again at this adoption timeout. So how does that actually work? So the adoption routine, it was actually correctly adopting the tasks. Yeah, and as I mentioned, let's take a look at this adoption task timeout. So it checks if the task actually executed on time. And that's this function, remove stalled adopted task. It basically checks for each adopted task. On line 2, we get the key and the time after which it's timed out, or we should kill it. It checks on line 3 if it's already past that time that it should time out. And on line 4, 5, 6, we are basically deleting the records of that task. So first it's saying like, okay, this task failed on line 4. On line 5, it's deleting the task record. And on line 6, it's deleting the adopted task timeouts record. Now let's compare this to the changing state handler that we found, because apparently in this distributed executor class, there was also a change state function. Yeah, and this was almost the same as you saw previously. Like line 2, 3, 4 are exactly the same as you saw in the previous slide on 4, 5, 6. But line 5 is a bit different. That one wasn't on the adoption time check. So that's where I found the bug. Because, yeah, we changed the event buffer, we deleted the task record, we deleted the adopted time record, but we missed the running record. So was the job still running or not? Well, obviously it wasn't running, because otherwise it would have been updated by that time. So what happened when a task would be rerun with the scheduler, right? That's when we got this error. Because every time this adopted task would be tried to be scheduled again, it would mean that it would still be in running, and thereby would again get this error for could not queue task. So what about running it manually? As I already mentioned, this does give you a high chance of repetitive strain injury if you do this for 5,000 tasks. But also there was yet another bug that caused these tasks to also die out very quickly. It felt a bit like this GIF, where the first bug was taking out this log out of the railroad, and yeah, we found the issue. So we felt like we were finally safe, and then yet another bug came and made our life a bit harder again. Yeah, great throwing skills if you ask me. All right, so we found the bug, and this is actually where the PR, where I created the PR. As you can see, we really only changed the 3 lines of what it originally was into the change state function that we saw. And yeah, this actually got quite some traction because many folks were having this problem. And a lot of them weren't using Apache Airflow on our scale, so they could often fix it some other way, but we really needed to fix it. And although I showed it in a bit of a simplified version, the code base actually had at the time 385,000 lines, and so it was quite a bit of navigating in through the code to actually find the issue. So I felt a bit like this dude here walking away from the fire, really happy to have found a solution. But yeah, of course, Airflow doesn't update within a day, so we still needed to handle the situation as it was at the moment. So yeah, how do we prevent this, or how do we fix the issue at hand without waiting for Airflow to update? The problematic states were really scheduled and queued, because if it were in these states during the adoption, then then this issue would occur. So basically, when we restarted the scheduler, we really needed to prevent that it was in scheduled or in queued state. So what we really needed to do was every time we wanted to restart the scheduler, we needed to forcefully shut it down, and then go into the web interface and search for all task instances that were on queued or on scheduled, and basically set them back to none, and then start up the scheduler. And that basically made the issues go away. Yeah, as you can see here on the right side, Ash B, the creator of the the one who refactored the entire code, he also had no idea at the time what the issue really was. And he was sort of as an idol to me, so it was really cool to see him reply to my messages. Yeah, all right, let's summarize. What are the lessons that we learned? When something is on fire, all hands are on deck. So I remember being there with Jelle Monk and Inigo. We had a debugging session of around 4 hours. Then the next one is restarting doesn't always fix your problem. It can make it a lot worse. Yeah, so we had a functioning Airflow, but then after the restart, it was completely gone. Nothing worked anymore. The third one, when you find an issue, try to contribute it back. It gave me a great feeling, and you're helping out a lot of other people. And also, once you start a habit of contributing, it can become quite addictive, or at least it can set the example for upcoming PRs. So since that moment, our team has actually done 10 PRs. I think that's really great, and we should continue this habit now. Yeah, I'd like to finish off with thanking the teams. It was really a team effort, although I'm the one presenting this and I'm the one who made the PR. This was definitely not only me. Yeah, so I'd like to thank Jelle, Santosh, Jan, Ravi, and Mirte. Also, I'd like to thank the data infrastructure group, but in special Inigo. He was there during our long debugging session. But of course also Hagar, Pedro, Antonio, Adrian, Corey, and Makoto. And finally, I'd like to thank the guys at Astronomer, who are the ones who are now actively maintaining Apache Airflow. Some credits for Giphy, like all of the GIFs that I used. All right, thank you. That was it. Are there any questions? I'll give you some time, so I'm not leaving without any questions. So. No question? Oh, this is gonna be awkward. All right. Did you get a button on Git? A button? I'm not sure what you mean, Robert. Badge. I don't think, yeah, actually I got a badge that I'm a contributor now to Apache Airflow, but not like one of the cool badges like part of Apache Foundation or anything like that. Maybe that's for the future to come, hopefully. All right. If there's no further questions, thanks a lot. And yeah, if you have any questions later on, just feel free to message me. Have a nice day.